Find arc length as a function of theta along the hypocycloid where alpha 1 is equal to r naught minus r cos theta plus r cos r naught minus r divided by r into theta. Alpha 2 is equals to r naught minus r sin theta minus r sin r naught minus r divided by r into theta. Alpha 3 is not given, it means alpha 3 is 0. We know that arc length as a function of theta is equals to integration of alpha prime of theta, norm of alpha prime of theta. Limits of integration are 0 to theta d theta. To find arc length, I need magnitude of alpha prime of theta. So let us first find derivative of all the component of alpha. Alpha 1 prime is equal to, here r naught is constant, r is also constant. Derivative of cos theta with respect to theta is minus sin theta plus, here again r is constant. Derivative of cos r naught minus r divided by r into theta is minus sin r naught minus r divided by r into theta into derivative of r naught minus r divided by r into theta, that is r naught minus r divided by r. Here r naught minus r divided by r into theta is in the angle of sine. Here is r, here is r, we can cancel r. So what we have, r naught minus r naught minus r sin theta minus r naught minus r sin r naught minus r divided by r into theta. It is first derivative of alpha 1. Now let us find the derivative of alpha 2. Derivative of sin theta is cos theta. Derivative of sin r naught minus r divided by r into theta is cos r naught minus r divided by r into theta into derivative of r naught minus r divided by r into theta, that is r naught minus r divided by r, because I know derivative of theta with respect to theta is 1. Now again r with this r is cancelled. I cannot cancel this r with this r because here r is in the denominator of the angle of function cos. r naught minus r cos theta minus r naught minus r cos r naught minus r divided by r theta. It is first derivative of alpha 2. Since alpha 3 is 0, so its derivative is also 0. Now let us find magnitude of alpha prime. It is equals to square root of alpha 1 prime square plus alpha 2 prime square plus alpha 3 prime square. Now let us substitute values for alpha 1 prime, alpha 2 prime, alpha 3 prime. Minus r naught minus r sin theta minus r naught minus r sin r naught minus r divided by r theta square plus r naught minus r cos theta minus r naught minus r cos r naught minus r divided by r theta square plus 0 square and there is a square root on alpha 1 square plus alpha 2 square plus alpha 3 square. So I have magnitude of alpha prime of theta is equals to this. Now I can take square of this term, square of this term. So it is equal to, here is minus, here is also minus. If I take minus 1 common, then minus 1 whole square is 1. Right, so now I can easily apply the formula of a plus b whole square. So I have r naught minus r whole square sin square theta plus r naught minus r square sin square r naught minus r divided by r theta plus 2 r naught minus r whole square into sin theta into sin r naught minus r divided by r theta. Here is negative sum. So I will apply the formula of a minus b whole square. So I have plus r naught minus r whole square cos square theta plus r naught minus r whole square cos square r naught minus r divided by r into theta minus 2 r naught minus r square cos theta into cos r naught minus r divided by r into theta. Here is square root on the whole term. Now I can apply the identity sin square theta plus cos square theta equal to 1. So I can combine these two terms. I am calling it 1. I am also calling it 1. Since sin square theta plus cos square theta is 1, so I get r naught minus r whole square. Now here I am calling it term 2. Here is sin square. And here is cos square. So I am combining these two terms. So what I have plus r naught minus r whole square here is sin theta, sin r naught minus r divided by r theta. Here is cos theta, cos r naught minus r divided by r theta. So here I can apply the formula for cos alpha minus beta. I am taking minus 2 r naught minus r square common. So what I get? Cos theta into cos r naught minus r divided by r theta minus sin theta sin r naught minus r divided by r theta. Here is whole power 1 by 2. Now it is equal to 2 r naught minus r whole square by adding these two terms minus 2 r naught minus r whole square. Now I can compare this term with cos alpha minus beta. So what I get? Cos theta plus r naught minus r divided by r theta by using the identity cos alpha plus beta is equal to cos alpha cos beta minus sin alpha sin beta. And that's why I take minus 2 common, because there is no negative sign with cos alpha cos beta, but there is a negative sign with sin alpha sin beta. So I have magnitude of alpha prime of theta is equal to here I can take this 2 common, and when I will take it common outside from the square root, I will have under root 2. Similarly, I can take r naught minus r whole square common, and when I will take it outside from the square root, I have r naught minus r. So I am left with 1 minus cos theta plus r naught minus r divided by r theta. I can simplify this term by taking LCM. have 1 minus cos r theta plus r naught theta minus r theta. Here is power 1 by 2. Now this r theta with this r theta cancel because of alternate sign. So what I have, it is equals to under root 2 r naught minus r 1 minus cos r naught theta divided by r. Now s is equal to integration of the function magnitude of alpha prime of theta and integration limits are 0 to theta. Let us substitute value. Under root 2 r naught minus r 1 minus cos r naught theta divided by r whole power 1 by 2 d theta. Now this term is constant, but I need to simplify it to find integration. I can take constant term out. No, 1 minus cos r naught theta by r is what? I know I can apply the identity. Sin alpha by 2 is equal to plus minus under root 1 minus cos alpha divided by 2. So from here I have under root 2 by multiplying under root 2 on both sides. Sin alpha by 2 is equal to under root 1 minus cos alpha. Here I will avoid negative sign because for hypocycloid theta is from 0 to 2 pi, and in this range sin alpha by 2 cannot give negative value. If I put alpha 2 pi, I have sin pi, and if I put alpha 0, I have sin 0, and between 0 to pi sin function is positive. So for given values of theta, I can avoid here negative sign. So what I have here, under root 2 sin r naught theta divided by 2r, because for the given case alpha is r naught theta divided by r, and here is sin alpha by 2, so I have sin r naught theta divided by 2r. Now I can easily find the integration. It is equal to under root 2 r naught minus r. Under root 2 is again constant. I know that integration of sin x with respect to x is minus cos x, and integration of sin ax with respect to x is sin ax divided minus cos ax divided by a. So I have here minus cos r naught theta divided by 2r divided by constant term, that is r naught divided by 2r, and limits are 0 to theta. Under root 2 into under root 2 is 2 into r naught minus r. Here 4. 2 into 2 is 4. R divided by r naught. I am just doing cross multiplication. And when I will apply limits, I have minus cos r naught divided by 2r into theta, minus minus plus, cos 0 is 1, right? So this is my answer. I have found arc length as a function of theta for the given hypocyclite.